Okay, we are now going to move on in our discussion of exponentials and logarithms to the other half, which is logarithms. So, we'll go through a very basic introduction to what we are, to what they are, before in the next few videos we will have a look at how we use them, how we draw them on graphs, etc, etc. But all we want to talk about today is what are these things, these logarithms? Well, essentially, they are the inverse of exponentials. So we saw last time that something like 2 to the x is an exponential. And a logarithm is the inverse of that, the same way plus is the inverse of minus and times is the inverse of divide. A logarithm is the inverse of an exponential. So why are these useful? Well, in a case, for example, I have 4 to the x is equal to 64. Well, you and I may look at that and go, okay, well, obviously x is 3, 4 cubed is 64, that, 4 times 4 times 4 is 64. And yeah, that's fine. But if this wasn't 4 to the x is 64, if it was, I don't know, I'm going to make up some numbers, if it was, 27 to the x is equal to some horrible looking number in the tens of thousands. I don't know my 27 exponents, but then it would be a bit trickier. We wouldn't be able to just look at it. So what do we do? Well, the same way that if this was 4 times x was 64, we would divide both sides by x. We do the inverse. We're going to do the same thing. Instead of having an exponential, we are going to inverse it, and we are going to apply a logarithm. Now, the way that we do that is we write this log base 4 to the x. This is applying a logarithm to this side. Now, this little number down here is the base. It is whatever the exponent is being applied to. If this was 2 to the x is 64, then this would be a 2. If it was 10 to the x was 10,000, this would be a 10. And we'll have a look at that in a second. But the idea is we would apply this magic log of base 4 function to this side. Now, because, remember, think of it as a normal algebraic function. If we multiplied both sides by something, if we multiplied one side by something, we have to multiply the other. So we've applied log of base 4 to one side. So we are going to apply log of base 4 to the other side and throw it all in there. Now, the same way, once again, if this was 4 times x was 64, we would divide both sides by 4. My 4 would cancel. I'm left with an x. The same thing happens here. This log to the 4, log of base 4, cancels out the base. As long as this base and this base are the same, these numbers will cancel out. And so will the log. The whole function disappears. So log of base 4 and the base 4 cancel. I'm left with x is equal to log base 4 of 64. This is where the writing kind of stops, and we're going to need to put this into our calculator. Once we put this thing here into our calculator, this will give us a 3. Try it. Type in log base 4 64 into your calculator. It will give you a 3. X is equal to 3. This is the kind of bare basics, bare bones, what is a logarithm. So let's have a look at a few more examples. Let's have a look at these 3 examples. 2 of them will come up quite importantly in a minute. First of all, to notice, I have highlighted the base in red each time. Okay, that's what the red here signifies. So 3 to the x is 243. So I'm going to apply a log with a base of 3. It is the thing the x is acting on, to both sides, equals log base 3 of 243. Log of base 3 cancels with the base, so x equals log of base 3 of 243. Pop that into the calculator and you get 5. Now over here, 10 to the x is 10,000, 10 is the base, so apply log of base 10, 10 to the x. equals 10,000. Log 10 and 10 cancel. X equals, I forgot to apply it to this side, log of base 10 of 10,000. Type that into a calculator and you get, what's that, cubed? No, to the 4. X equals 4. And then finally, e to the x is 7.389, and that goes on for ages. And remember, e, Euler's constant, Euler's number that we looked at last time, very, very important number in exponentials. We would once again take the base, do log base e to the x is equal to log base e of 7.389 going on for ages. Log e and e cancel, and x is equal to log of base e of this number. Now, to get the exact value, it's going to have to go on for ages because this is a decimal, but it will give you approximately 2, because e squared, which is 2.7 roughly, squared is 7.389. Now, what was so special? Why did I choose the 10 and the e? Well, there's a good reason for that. These two logarithms here, log of base 10 and log of base e, are the most common logs that we use. In fact, in my however long I've been using logs, nearly a decade, I have maybe 99% of the time used log of base 10 or log of base e. And this tends to be the case with any form of mathematics or science that you do. Because of that, we've shortened how we write these two. Log of base 10, and you will see this button on your calculator, is simply written as log. So on your calculator, you'll see a button that just says log. There's no number at the bottom of it. There's no way to put in a number at the bottom of it. It has a hidden 10. Log of base 10 is just log. So if you ever see just log written with no number, it is a hidden 10. The same way that 1x, we don't bother writing the 1, we just write the x. We do the same here. Now log of e, probably the most common type of log. We kind of saw why in the last video. E to the x has a lot of very nice looking properties, especially in calculus. So a lot of the time, to get our x, we want to apply a log of base e to this. Remember, cancel, cancel, get the x. And because of this, we write log of e as ln. Ln. That's how I pronounce it, as a lot of people do. Ln. It's not even a log anymore. I mean, it still is, but it's not the word log. It's now ln for ln. There's no base written in. It's just ln. Ln
I
x.
believe it's raining right now.
Thanks, Siri. I'll leave that in. Ln x is the same as log base e of x. These are the exact same. But again, you'll see this button on your calculator, and it simply means the log of base e.